Hi guys, today let us learn about anodizing. The process of deposition of an oxide film on a metal surface is known as anodizing. Anodizing can be done on aluminium and titanium. See, we all know the process of oxidation wherein a metal, when it is exposed to oxygen and moisture, gets an oxide layer on it. So it becomes a process of oxidation. Now, this oxidation is done in on aluminium, okay, and it is having a lot of industrial application. See, when it comes to the metal bottles, right, or even motor vehicle components, or even jewelry. So here you can observe it's a ring, okay, that women wear in that ear, and you can see how there are 12 to 13 beautiful colors. So this is an example of anodizing. So they have taken a normal aluminium earring, and on that they have done the process of anodizing, and you've got these beautiful colors. So anodizing is having, as I already told you, a lot of industrial application because one is that it is corrosive resistant. See, any metal, it's not only about iron, even if you talk about any metal, it always undergoes corrosion. And corrosion is a major disadvantage on the durability of the metal. So hence, anodizing helps prevent corrosion, and also it increases the lubrication and addition. And one more most important thing is that the oxide layer once produced formed on the metal does not chip or peel. So this way we can increase the durability. And of course these days anodizing is also being used in the interior of homes and also on the outer surface of buildings. Okay, so these are some of the main applications of anodizing and importance of anodizing. Now let us look into the mechanism. Okay, so the process starts with the tank, electrolytic tank, mainly comprising of sulfuric acid. So this all this gray shade is nothing but sulfuric acid. Now sulfuric acid, as it is a good oxidizing agent, it is having oxygen in it. And the blue line, blue is the anode, that is pure aluminium. And red electrodes are a non-reactive metal. So either lead is taken, or it can be aluminum itself, because it will not react because they are of the same. Again, it's anode is aluminum and cathode is aluminum. There won't be any competition between the metals. Or also graphite can be used. So these three are non-reactive, means the substance or the oxide layer will be formed effectively on anode if we make use of non-reactive cathode. So if there are any metals react more reactive than aluminum. See, suppose you take magnesium or sodium, then obviously anodizing will not happen because sodium is more reactive than magnesium. So that's why a non-reactive metal like aluminum or lead or graphite has to be used for cathode. So the red lines are cathode and the blue line is anode. So that's aluminum. So now once the electric current is passed, so this again nothing but a electrolysis kind of, and here but this method is called as anodizing because here what is happening is from the sulfuric acid oxygen goes on adding to the metal, that's aluminum. Okay, so now we all know oxidation is addition of oxygen or removal of electrons. Now the added electrons, so the electrons will be now in the solution, so these electrons go on adding to the cathode, or in other words hydrogen. Hydrogen gets added to cathode while oxygen gets added to the anode. So now aluminium on reaction with oxygen will form aluminium oxide, Al2O3. So this is how oxide layer is formed on aluminium, and this is called as anodizing. So as I already expressed previously, anodizing is used in automobile spare parts also. So let's say a customer wants have a different style of the vehicle, wheels in his car. Then he can make use of these vibrant colors by anodizing rather than the normal gray color or silver color frame in his tires. Okay, so these are some of the applications of anodizing. Okay, thank you.